Welcome back to our learning session. Today we'll be learning some R coding and we'll continue from our last learning session where we stopped at question number 14. Today we'll continue from question number 15. This question says that we need to insert some title to the graph plot we created earlier. It's a graph plot we created earlier. Now we need to put some titles to that. And the way to put title is labs. That's the command we need to put title. Now question here is where we need to put this small command, where we need to put this instruction. The choices are there are different numerical Roman numerals that have been provided 1, 2, 3, and 4. Where we need to put it, and that's what we need to decide here. Now let's start by putting the numerals. Let's just put numerals at the end because that's what I think it should be. Now let's put it here and see what we get. And there you go. We have what we wanted. Now we'll move on to the next question. Question number 16. It says one thing we could improve in this plot is x-axis labels. First, we can remove the leading x. Second, by storing them as a numeric, ggplot can use its optimal scaling to make it prettier plot instead of having a label for each year. To do this, we can transform the year variable using Gipler's mute function and combination of function as numeric and stringer package. To try to figure out a few ways to do this. So we need to execute this command here. Which of the following statements are equivalent and can be used in blank statement below? So we have been provided a question here. How to do this? Do you have any idea? Well, let me see. Let's start by filling this out. What we can do at first thing at get-go is we need to look just for the year. We don't need XX, right? We just need the year part. So what we can do is we can do substring. We have a function called substring, string sub, and what we'll do is we'll take this year part from the string, and once we do this, the string the year year like 2001 2002, which is in string, will be converted to a numeric form, and then it will be assigned to the column called year, and then we'll plot a GG. We'll do a GG plot as we did earlier, and let's see how does that work. Let's see what we'll show you. And if we do this, we have a different graph, but improved x-axis, where we have a year which is not cumbersome as we have earlier. It is much more cleaner now, and this is what we wanted. Moving to question number 17, it is asking us which of the following statements can you conclude from the plot? The rate of the world average is always below the rate of the high and middle income countries. This is a world average here. This is a world average. And it says the rate of the world average is always below the rate of high and middle income countries. Below. It's not right. It is always high. This is a high income, and this is low income, and this is middle income. So what it's asking is, it's always below high income. High income is here. It's below. It's not. It's above high income, right? So this is not true. Second is, while the rate of high income countries represent decreasing trend in a period, the rate of low income countries fluctuates until the mid 19th century, when it becomes decreasing significantly. When it's decreasing significantly, and we see that it is true. This is true. And a gap between high and middle income countries is lower in 2014 than in 1960. This is also true. And third is, since the mid 90s, rate for low income countries has decreased more than it has for high and middle income countries. That is also true. Therefore, except the first statement, all other statements are true. Now, moving on. Now we are not going to consider trends of different categories over a year. Instead, we are going to compare how the distribution of the adolescent fertility rate is different between 1960s and 2000. We have provided our script, and we will look at it, and we need to do some answer a few questions based on that script. This is our script which has been provided, and we'll run this script to see what we get. We get this graph here. It's a distribution graph, bar distribution graph, and we need to answer a few questions based on this. The question is, for this command, what we have is, there are several parameters here. You're asking question, what does alpha dictate? The alpha here, what does it mean? In argument, there's some argument called alpha. What does it mean here? ggplot and geom has something called alpha here, alpha 0.2. And from what I understand is that alpha is a level of transparency of color of bins. So this is a select. This is going to select. And question number 19. As you can see, we have certain number of bins in the figure. Go to our documentation and answer the question. Does it allow you to change number of bins in the figure? And the right answer is bins. This will allow us to change the number of bins in the figure. This is a default, and this allows, if you change the number of bins here, if you add a bins parameter, then it'll allow to, we can change the number of bins here in this figure. So that's it. Let me quickly summarize what we learned today. We'll learn about a few things today. Starting with question number 15, we added a title of the graph using a labs function. And in question number 16, we mutated a field year such that we don't have x before a year, and we remove the x and we convert a year into a numeric field such that we can utilize the R's optimization function to make the plot much prettier. In question number 17, we'll look at the graph and try to see which statements are true or false. And in question number 18, we'll look at the commands for R and so like what's the meaning of alpha in the command. And question number 19, we asked how can we change number of bins, and we answered that too. So that's all for today. Thank you so much.